dynamic formulae. So within this, we will start first one. First one is, I will use another color. It doesn't matter for me. ENR formula. Someone can ask me, sir, what is ENR formula? So ENR means, I can tell you, engineering news record. This is a very popular magazine. It is actually it is published from the London. It is a popular magazine, just like we are having journals and magazine. So in this particular magazine, Wellington is the person who published this article. He has given one equation to calculate ultimate loading capacity of the pile. That is equal to QU is equal to WH by S plus C. So I know you may ask different questions. Sir, what Wellington is mentioned in his what is published in Engineering News Record. This is a magazine actually. Name of the magazine. In this magazine, Wellington has published his work. He has written one article on how to compute load carrying capacity of the pile. So actually, this is the formula given by Wellington. I can tell you one thing. What is QU? Ultimate load. And you may ask me, sir, what is with W? W is weight of the hammer. Weight of hammer. So undoubtedly you can predict what is H, height of fall. So now you see, sometimes you are very much interested to ask what is S. I can tell you, S is penetration. C, in fact, you see is elastic compression. Elastic compression. So this is an empirical formula proposed by Wellington, and his equation is very simple. Now someone can ask me, sir, what is this actually? So I already drawn one picture. Again, I will draw. This is the pile. In fact, actually, Wellington proposed his formula, ENR formula, for the driven pile actually. This is the weight of the hammer. I can show you. For me, it's very easy also. So I don't mind to draw any picture. Yes, I will show you. This is the schematic diagram, because schematic diagrams are very interesting to understand. So this is the crane actually. You can see this diagram. I think you will be very happy now. You see, actually this pile top is having packing actually. Many times driven piles having a packing. You know what do you mean by packing? Packing means it's very simple to understand. We used to use some plywood sheet. So many people has done a lot of research work. So many PhDs also guided. Even L&T people also worked in this direction. So what kind of cushion is a better material? They found that the plywood is also a suitable material, which can actually, while you are hitting the top of the pile, there is a likely chances of damage of the pile top. So in order to control damage of the pile top during this application of the hammer energy, so they want to reduce this. So without any damage to pile top, they are trying to put some packing. This we call cushion also. So many times we used to use this jute cloth, and also we are providing plywood so that we can able to resist the damage happen at the top of the pile due to hitting of this hammer. This is a hammer. So in fact, actually the idea of this Wellington is, he just applied our energy conservation principle. The amount of energy applied for driving the pile, is equal to the pile load carrying capacity. I can tell you once again without any hesitation. So because in my masters, we used to read a book, wonderful book, Pile Foundations by Tomlinson. So Tomlinson has clearly mentioned actually the Indian books, what we read actually in general, they are not opening. They're just writing the formula and running away. but we will discuss now. We have a good amount of time. It's good to discuss the amount of energy you are applying. What energy you are applying, weight of the hammer and height of the pole. So W into H. Can anyone tell me what is this? Energy is equal to QU. Now someone can ask me, what is S plus C? QE into S plus C. See, when you apply the load, there may be some compression. So what I say, elastic compression, so rebound. So altogether, that's a QU into S plus C is equal to W into H. So I want QU, load carrying capacity of the pile, WH by S plus C. So now someone can ask me, sir, can you tell me how to calculate allowable load? So now allowable load is equal to QU by factor of safety. So let me tell you, factor of safety here, because of so much uncertainty, the Wellington has proposed 6. Whereas in dynamic formula, so because you see, there may be a lot of energy losses. We know that there may be a lot of energy losses. One knows that. So because you see, we are hitting the pile, whatever the energy, there may be some, losses in energy. So due to the load may be transferred to the neighboring soil. So because of that, there is a lot of energy loss. So that's why you see, many times we use it to consider a factor safety 6. So the second one is also very interesting. That is a Hiley's formula. Actually, there is no much difference between Enr formula and Hiley's formula. Both comes under dynamic formulae. QU same what we discussed in the last one. QU is equal to WH eta H eta HB by S plus C by 2. So now the thing is, కనబడుతుందండి నేను రాసేది మీకు. QA is equal to QU by factor of safety. But this time, actually in the Hiley's formula, whatever the weight of the hammer and height of free fall of this hammer, and S is the penetration of the pile, C is the elastic compression. Here in Hiley's formula, we are writing here eta H. I am very sure what I am writing. Eta HB. Eta H means efficiency of the hammer. So whether see, efficiency is very important, as you know. Efficiency means output by input. So many times you see, we are trying to say our hammer is efficient, but we are not sure. You see, while we are applying the, repeatedly I am telling during SPT also. So when you are hitting the pile with this dynamic impact energy, what happens, you see, when you are hitting, there may be some energy loss. We are not sure every time we are maintaining same height of fall. That's why we should consider efficiency of hammer and hammer blow. What I tell you, efficiency of hammer blow. So here you see, in fact, is eta H. This is eta. I can write in Telugu. Eta. So eta is a symbol actually. It is not N. Eta. Eta H, efficiency of the hammer as well as hammer blow. Hammer blow. So these two things are considered by Hiley, because he is not just saying that whatever the energy you are applying is equal to the load carrying capacity. He feels that the energy, whatever the energy we are applying, it may be lost. It may be lost. So some energy is lost. So that's why it is because of the hammer, because the hammer may not be efficient, whatever the hammer we are using, and also hammer blow. So that as duly considered by Hiley. So the above formula is a little bit modified. So now we have ultimate load, and apart from that ultimate load, we can able to calculate allowable load by applying factor safety. So here eta H means efficiency of the hammer, HB means efficiency of hammer blow. So this is Hiley's formula. But the thing is, eta H is the efficiency of hammer, Eta HV, we have a formula. If W is greater than EP, then efficiency of hammer will be W plus E square P by W plus P. So now you are ready. I think you are ready to ask one question to me. So what is W? Weight of the hammer. Now you can ask me what is E, what is P. I am ready to tell you. P is weight of the pile. Weight of the pile. You know how to calculate weight of the pile means gamma of pile material into volume of the pile. Volume of the pile. This you can able to calculate. If it is a cylindrical pile, we can get a surface area into length. What I say? Perimeter into length. So now you see what I'm trying to tell you. So here you see P is the weight of the pile. Now E is coefficient of restitution. Coefficient of restitution. Restitution. Okay, that's good, I think. So E is coefficient of restitution. Sometimes you are very much interested to know what is restitution. Restitution means rebound. Rebound. When you hit the pile, so what happens sometimes you see there may be rebound. Rebound means what I say, it will come back. Rebound. So rebound, restitution. So E is the coefficient of restitution. As long as your weight of the what I say hammer is greater than EP, you can use this formula W plus E square P by W plus P. So this is simple formula. If W less than EP, we have a big formula. Anyhow, that may not become appear in UG classes, undergraduate classes. We won't go that much level. Even actually ENR is enough. But I am in a dilemma whether if you see sometimes in your VR exams also they are asking this question. That's why I just opened this concept. So anyhow, the today's discussion is about dynamic formula. Within dynamic formula, as of now we discussed ENR formula. So today we are discussing Hiley's formula. Here the WH by S plus C by 2. But here in Hiley has given a modified ENR formula. He has given he has taken account of efficiency of hammer and hammer blow. So there is a formula for hammer blow that I am trying to show you here. You see here W greater than EP. W means I can tell you W means weight of the hammer. P means pile weight, weight of the pile, weight of the pile. So we can able to calculate weight of the pile by knowing gamma pile into volume. You know, because gamma is equal to weight by volume. So from fundamentals we can get weight of the pile.